figuring out exactly what actions one needs to take to make this thing swing the pendulum in the upright position. But instead of spending hours and hours on a computer trying to figure out exactly what motions to do, to break the problem into two parts. The first part is using a simple model, apply some powerful mathematical techniques known as optimal control to give you a rough guess of what you need to do. And then, by learning, improve that, and so you can eventually make this thing stand upright. So, talk a little bit more about analyze whatever you like.
I guess my main idea is actually that normally you have a quite good idea how the system behaves approximately, so you know if you push here in this direction. But in order to really predict the behavior precisely, you need to identify the parameters very correctly. And it takes a lot of experiments and measurements before you actually can do what you really very intended to do. And what we are doing is we use a very simple model, apply an input which should do what we want to do, but we know our model is not correct, and then we use several trials to take both gain experience, take measurements, and improve the behavior. So what you see here, we're going to play with the pendulum, and first, the first trial is not successful. We will be also repeat. So that means not successful, and the pendulum tries to come back to the initial position and start a new trial. And most of the time, after 3 trials, we can pick up. So the pendulum learned enough about the friction and all the complicated dynamics going on, and it's still successful in doing that.
We should introduce our other helper, Angela.
Yeah, this is my student Fabian, and he basically did the whole automation of this thing. So coming back again to the initial condition immediately. Everything that works just pressing one button. So this was the first trial. We tried to get back to the initial condition.
It knows there's a lot of people watching this. So, just very quickly before we move on, so how does this differ from other learning approaches, and specifically machine learning approaches that probably many of you are familiar with? We're trying to combine knowledge of dynamics. So when we said this is a simple model,